All right, I think now it's 8:05, so let's get started. So hello, everyone. Thank you for attending the workshop of practical mediation analysis. And this workshop is supported by ISDSA and also SMAP. I'm Laura Lu from the University of Georgia. And Jackie and I prepared this workshop for us, okay? So let's look at the outline first. So after a short introduction, I'm gonna talk about traditional mediation models. And Barry and Karen's paper will be our focus, and also Sobel test. And of course, we will have some examples. And after the traditional introduction to mediation, we will have some, bootstrapping method on mediation analysis, because in the traditional mediation, we will talk about some traditional method, and then we can look at the bootstrapping method on mediation. And we also have missing data issues. So we're gonna look at the methods to deal with missing data. And after that, we will move forward to advanced mediation analysis, which includes multilevel mediation, longitudinal mediation, and of course, if time permits, we can look at some other advanced models, for example, causal mediation, network mediation, and others. And we will have some examples. All of these examples will be conducted by using R and M+, okay? Okay, that is the outline of today's workshop. And again, we will have 3 hours workshop. So now it's 8. So after 1 hour and 2 hours, we will have short break. Okay, maybe 10 minutes for each break. Okay. Okay, I'm sorry. Okay, introduction. Mediation is very popular, okay, nowadays, because it can help us to understand the mechanism through which the input variable affects outcome, and of course through some mediation models. So look at the paper. So Barry and Kenny had a paper published in 1986, and this article has been cited over more than 120,000 citations in 37 years. So mediation, you can see that mediation is a very popular model. This model actually is a causal model. It's not defined statistical model. And in this model, the mediator is presumed to cause outcome and not the vice versa. So we have a presumed model. If the presumed model is not correct, then maybe it's not very useful for the result, to explain the result. The results from the mediation analysis of little value. But we can use certain ways to look at the this model, okay, or 2 equations actually. So let's look at some examples to address. We are going to use mediation models to address some problems. For example, does physical abuse in early childhood lead to deviant processing of social information that leads to aggressive behavior? So in this research question, actually we can see there are 3 variables of physical abuse in early childhood, and then that one will lead to another variable, deviant processing of social information, and this variable leads to another one, the 3rd variable. Okay, so aggressive behavior. So 3 variables involved in this model. Let's look at another example. Do expectations start a self-fulfilling prophecy that affects behavior? So again, 3 variables involved, and the one causes the other one, and the leads to another one. Okay, so the third one. The third example, so does trauma affects brainstem activation in a way that inhibits memory? So again, trauma, it's kind of like input, and that one affects brainstem activation in a way that inhibits memory. So 3 variables. The second rehearsal increase image formation, which increases word recall. So you can see that mediation is kind of like a causal model. So we have some cause, we have effect, yeah, we have outcome. So what is a mediation model? So let's look at this in the next session. So we're going to talk about the mediation model and some basic concepts. For example, indirect effect, direct effect, total effect, complete mediation, partial mediation. And then, of course, how are we going to conduct mediation analysis? And again, I'm going to cite 2 papers, the Barr and Canis paper and also Sobel test paper. So these are related readings. Let's start from a very simple model, okay? Simple linear regression. So we have 2 variables involved. We have X and Y. So in this case, X gonna cause Y, and we assume the weight or the coefficient is C. So this model can be written as, okay, Y is C times X plus some residual, okay, E part. In the path diagram here, we actually simplified the residual part. We use a double-headed arrow here to show we have variance here. But this one, this variance sigma E square is not variance of Y. Actually, it's a variance of the residual part. Residual of the Y, it's E part. So we use a simplified path diagram and to show this equation. And the variance of X assumed to be sigma square of X, and the residual variance is sigma E square. Okay. That is simple model. Now let's try to introduce a third variable into this model, M. So if the relationship of F, X and Y is mediated by M, the third variable, and we have this model. So this is called mediation model. So X gonna cause M, and at the same time, X gonna cause Y, and the M here, M is called a mediator, gonna cause Y. So we have 3 paths here, and of course we have 3 variables. So M here, as I mentioned, it's called a mediator, and we see that effect of X on Y is mediated by a third variable M. Of course, you're gonna check the strength of A times B. If it's significant, then we can see that there's a mediation effect. Otherwise, we can say that, okay, there's no mediation effect. So in summary, we have 2 equations. So one equation is for M. If you look at this part from X to M, then M is the outcome and X is the input variable or independent variable. So we have an equation between M and the X. M is A times X, because the coefficient here is A, and some residual. Okay, so EM, the E belongs to M, is a residual of M. And we have another equation about, okay, Y is a dependent variable. So Y is a combination of 2 parts, X and M. The coefficient from X is C prime, and the coefficient from M is B. And these are 2 components, and we also have a residual part. We have E, the residual part of Y. So we have the second equation. And these are the variance part is a kind of like the previous slides. So the variance of X here, the variance of the E here, and also we have the variance of the residual of M here, okay? These 2 equations is called a mediation model. So let's do the introduction of the concepts, some basic concepts. So if we ignore the M variable, so we have X goes to Y, and the C here is also called the total effect in mediation model. So it's total, okay, total. And let's look at the other path diagram. So we have C prime, we have A, we have B. So the product of A and B is called indirect effect, or it's also called the mediation effect. And then we have C prime, which is called direct effect. So you can see that from X to Y, so we have kind of like two paths. One is from X to M to Y, and the other one's directed to Y. So C prime is called direct effect. A times B is called indirect effect. The sum of these two paths, the C prime and A times B, is just our total effect, C. So we have this equation hold for mediation. So total effect is the sum of direct effect, C prime here, and indirect effect, A times B here. Now let's look at the two cases in mediation model. So we have complete mediation, and also we have partial mediation. So what is a complete mediation? Think about the concept of complete mediation, complete. So when we have a complete mediation, the C path, the C prime is 0. So here, this part becomes 0 after introducing the M into this model. So the effect from XY is completely mediated by M. C prime is 0. But we also have partial mediation. So from X to Y, so here the strength is reduced in absolute size, but still the C prime here is not 0. Okay, then we call it partial mediation. So how are we going to do the test? Okay, so the null hypothesis is just to test if A and B 0 or not. Okay, so if we have A here, B here, the indirect path is in A times B. If A times B is 0, then we can see that there's no mediation effect, or there's no indirect effect. So this null hypothesis is equivalent to C and C prime is the same. Okay, the total effect and the direct effect is the same. In that case, the A times B is just 0. So that's our H0. Then how are we going to do the test? Let's follow the steps in Barry and Kenny's paper. So it gives us some steps. The first one, they suggest that we needed to do the test between X and Y to make sure the total effect is significant. So the X here, the Y here, and we have C here. So Y is a dependent variable, X is an independent variable. We just want to know if C is significant or not. And then second step, we focus on X and M. Okay, we want to do the test of A, the path of A. And yeah, in this case, M is the outcome, and X again is an independent variable predictor. The third step, we're gonna look at B, okay, the coefficient B or path B here. But if you want to check the significance of B, you have to control the other variable X, because when you look at the Y here, the Y is a dependent variable. If you have the relationship between M and Y, and you also need to control X, you need to pay attention to X. So X is also involved in this equation. So X is covariate, and we focus on the B from M to Y. And the fourth step is to check the complete mediation. So if we want to test if the model is, if the mediation is complete, we need to check the C prime. If C prime is 0, then we can say that it is a complete mediation. If C prime is not 0, we can say that it's a partial mediation. But if you want to check the C prime, you also needed to look at the B path, because again, just like the previous step, so we have Y dependent variable here, and XM actually are both independent variables. These gonna cause the outcome of Y. So this step and the previous step actually is conducted by one equation. So if we have 4 steps satisfied, okay, we have first step C, second step A, third step B, fourth step C prime. If all of these 4 steps are met, then we can say there's a complete mediation. But if we have 3 steps are met, okay, but not the 4th step, so that means the C prime is not 0, but we still have the A and the B here. So there's a partial mediation. Okay, so partial mediation here. But let's take a look at these 4 steps. Are these 4 steps necessary? So the first one, check C. The second step, check A, and check B, and check C prime. So do you think that all steps necessary here in order to test A times B is significant? Yeah, actually the first step is not necessary, okay? Actually C here is not necessary. Because in some cases, the total effect is not significant, but we still have significant indirect effect A times B. Because the direction, okay, the signs of A times B and the C prime could be different. So if we have the opposite sign, then they canceled each other. So finally, when you look at the C here, because it got canceled, it could be non-significant. But it's possible that A times B is still significant. So in that case, the mediator is also called suppressor variable. Okay, it changed the direction of A times B and C prime. So in most cases, we only needed to test A and B, okay, step 2 and step 3. So that's suggestion from Barron's paper, okay, Barron and Kenny's paper. But actually we can combine these 2 variables together. We can just look at the product of A and B directly. So Sobel has a paper talking about the test of mediation. So we don't need to do several steps and check A and B separately. So in this case, we're gonna directly check the product of A and B. And we needed to get the distribution of A and B, the product of these 2, okay? And the key part is trying to find the standard error of this product. And in that paper, the standard error is approximately by using this term. Okay, so we have A squared times the variance of B. This is the variance of B because B is a variable here, and we have variance of B. And also the B squared, okay, plus the B squared, B is a coefficient here, and times the variance of A. Of course, there's some other terms, okay, which is about the covariance between A and B. But if we assume that the covariance of A and B is 0, then we can just ignore the third part, the third term. So it's approximation, not as an exact standard deviation. And after we got the standard deviation of A times B, and we assume that it follows a normal, approximately normal distribution, though we can use a z-test, okay, z-test. A times B divided by the standard error follows the z-test, follows the standardized normal distribution. So Sobel test actually is coming from a delta method. Delta method just describe the distribution of a function of some variables we know. For example, if beta here is set of variables and it has a distribution of normal, okay, with mean of beta. Beta is the mean of beta here. And then we have the covariance matrix sigma. This is a asymptotic covariance matrix of the beta parameter here. If we have this assumption, then h is a function. Any function of this beta b can be derived by using the delta method. So the distribution of HB is, of course, it's asymptotic. So when the n goes to positive infinity, so we have this distribution still normal, and the mean becomes h of this beta, okay? The function of the mean of the beta here. And then the covariance matrix here, it's a product of three parts. So again, we have the capital sigma here in the middle, and we have the first derivative of the function with respect to each parameter. Okay, so we have beta parameter, so we got the first derivative with respect to those parameters, and transpose and times the matrix here, and also we have the first derivative of the h with respect to the beta. So in this case, we have the distribution of function of beta. So A times B is a function of two variables, A and B. Okay, A, B are two parameters. So A times B is a product, which is a function of these two variables. So follow this delta method, we can derive the distribution of product of A and B. That's Sobel test. Okay, now let's try to look at some examples. So the first example is very simple. We just look at the three variables only, okay? So this is about the research. This data is from a public data set called National Longitudinal Survey of Youth, or we call it NLSY 79. And we just use a small subset of the whole data set. So we assume that the sample size of the small subset is 371. So there are 371 families. So in each family, we have mother's education variable. We call it ME, mother's education level. We also have second variable, home environment, okay, HE. And we have third variable, children's mathematical achievement, math. So those are three variables. So what is our model? What is our pre-assumed mediation model? So we're gonna look at the model whether home environment is a mediator in the relation between mother's education and the children's mathematical achievement. So in this case, let's just look at this statement again. So whether home environment, this is a variable, is a mediator, okay, and in the relation between X and Y. So which one is X? Mother's education, and Y, children's mathematical achievement. So we have M here, which is home environment, X here, mother's education level, and Y, children's mathematical achievement. Then we have this simple mediation model described here. We have ME, mother's education level, causes HE, home environment, which causes mathematical achievement at Y here. And of course, mother's education level gonna directly influence the kids' math achievement. So we have A here, and B, and C prime. And of course, we have three variables, three variants, okay? Variance of ME, variance of HE. Okay, this is residual of HE, not the direct variance of HE. And also the residual variance, the variance of the residual of math. And we're gonna conduct this model by using R or M+. R has a lot of packages, so we're gonna use a package called BMEM to do the Sobel test. Okay. So here we just use a Sobel test. We didn't follow the steps to test A first and another step to test B. So we combined this A and B and by using the Sobel test. So actually for data analysis, we have 4 steps. Okay, the first step, always prepare your data preparation. And second step, you need to specify your model. So whatever, in this case, we have mediation model. Of course, you can have some other SEM models. And third step is to estimate your model to obtain the parameter estimates. And the fourth step, just look at the result and understand those numbers and do some interpretation. So let's go back to our code. The first step, data preparation. So we have the package ready. So first you have to install that package and then use library to include, to make that package active. And you can also set your working directly in R. And then read the table. Actually the data is already saved as rdata.txt. And there's a header. So we have ME math, the title or the column name of the data, 3 columns. So we use a read.table to input the data into R, and we call it dset, dataset. And then the second step, okay, we're gonna specify our SEM model or mediation model. So in that package, we have, we can also use a package called SEM. So we have a function called specify model, and inside this part, we're gonna tell R, okay, what is our mediation model? And all of these commands are concluded by using this pound sign, and we call that is M1, the first model 1. So let's look at the inside of the function of specify model. So we have different rows. For each row, we have a parameter specified. For example, okay, for this part, we have A. For this part, we have B. So what are these components? Actually, inside each row, we have 3 components. We have first component, which tells us where's the path. Okay, so from ME to HE, this is the path from ME to HE. And we call the parameter A. Okay, we call the path or the coefficient A. And the third component is the starting values. So if you use NA, the system will assign a starting value for you. So that is for parameter A. And of course, we're gonna complete the mediation model by, okay, using the B here. B is from HE to math, the starting value NA, the system assign a value for us. And the C prime, okay, C prime is from ME to math directly. So in addition to these 3 paths, we also have variance or the variance of the residual of the dependent variables. So we have ME here. Here we have double-headed ME. That means that's a covariance. Sorry, that is a variance. Okay, variance because ME have the same name, variance of ME, and we call it S1, and starting value system assigned. And ME, double-headed arrow, the same name. So variance of HE, okay, I'm sorry, this is HE, home environment. This is a residual of HE. And also math, from math to math, the residual of math, the variance is named S3 and starting value NA. So we have 6 rows. So that means we have 6 parameters in this model and with the pound sign here. Okay, that is second model. We have data ready. We have our model ready. Then the third step, just run the analysis and to estimate the model. So in the BMEM package, we have function called BMEM.Sobel, just do the Sobel test. And then inside the parentheses, we have the data set. Okay, data set is prepared in the first step. We have the second component model. Okay, M1 is defined here. And we have something here. What is this? This is an indirect effect or other effect we defined here, okay, previously. So we called indirect effect, which is A times B. Then this will be estimated after you run the Sobel test, okay, BMEM.Sobel. And then finally, we're gonna look at the result, okay? All the results are saved here, and we use a summary function to look at the result. And we use $ to get the specific result, okay, $ SEM. So this is one kind of like a way. If you want to make it a little bit complicated, then let's try to add another component. So here we only have indirect effect. Let's just add a total effect. So as I mentioned before, total effect is the sum of indirect effect and the direct effect. So in addition to the A times B indirect effect, we have A times B plus C prime, which is total, because the sum of these two is total. So in this case, so the effects is defined at these two components. So after you run this part, the total effect and the indirect effect will be calculated. And of course, the standard errors or the p-values will be provided. And we can also use a summary function to look at the result, the SEM result. Okay. So that is a code. Yeah, we have already summarized the steps previously. Let's look at the results first, and then we can just open R Studio and do the data analysis. Let's look at the output from R. So all of these will be reported, okay, in addition to these 6 parameters, A, B prime, C prime, S1, S2, S3, we also have this component because we run this part, okay, the effects of indirect effect and the total effect will be reported. So in addition to these 6 components, we also have the indirect effect reported here and the total effects. So we have estimate, we have standard error, we have z-score, we have p-value. So based on the result here, we can say that, can you tell me if there's a significant mediation effect? Yeah, so look at the p-value here. It is, if the alpha level is 0.05, it is less than 0.05. And then we can say that the indirect effect is significant. So there's a mediation effect. And we also checked the total effect. Okay, the total effect is estimated value is 0.5 to 7. Okay, 5. Okay, standard error here, z value here, p value here. It is also significant. That is a parameter estimate part. We also have the model fit part. So it provides a model chi-square value, degrees of freedom, probability, okay, and ANC, BNC, and yeah, some other information. So let's look at the DF, degrees of freedom. DF means degrees of freedom. So why do you know? Okay, why it is 0? Do you know why it's 0? Actually, we can calculate the degrees of freedom manually and to check if it's 0. So the formula to calculate the degrees of freedom is described here. Okay, this is a D here. So what is P? What is Q here? P is number of observed variables. Okay. So P variables, in this case, in our case, we have 3 observed variables. We have X here, well, we have ME here, we have HE here, we have math here. So P is 3. P here is 3. So once we have this P, we can calculate the number of information. So P times P plus 1 divided by 2. This is the number of information. So P is 3. 3 times 4 divided by 2. 6 is the number of information. But what is Q here? In this formula, we also have Q. Q is a number of parameters, okay? Number of unknown parameters. So let's look at this table. Let's look at the model here. How many parameters did we estimated? So we have A here, we have B here, C prime, we have S1, S2, S3. So in total, we have six parameters. And the 6 is number of information. So the degrees of freedom is the difference between these two numbers, okay? Number of information minus the Q. So we have 6 here because P is 3. 6 minus 6 is 0. So that's why we have degrees of freedom 0 reported here. So that's correct. Okay, here we use this model. So we have another model without the mediator. Why do we want to run this model? We want to check the total effect because in these slides, we reported that the total effect is 0.527500. Okay, so we want to check if it is a total effect, then we can just run the simple model here, simple linear regression here. So we have ME, we have math without mediator. So how to translate the path diagram here into our R code, just like previously, yeah, just like the previous part here. So specify model, we have 3 parameters in this case. We have C, which is the coefficient from ME to math. And we also have S1, which is the variance of ME. We also have the residual variance of math, okay, S3. Then the syntax is described like yeah, okay, specify model. And of course, we have the pound sign to conclude these 3 lines. And then we use SEM. Because this is not mediator, okay? If you use a package of SEM, there's a function called SEM. So use the SEM to do the estimation. And we have the model here. This is the model for total effect. And the S, what is S? S is the covariance matrix of the data. So, and sample size, okay, sample size 371. So we have these 3 components for the function of SEM. And then we can use summary to look at the result. So that is the outcome. So still we have the degrees freedom reported, we have BIC, but this is for the model here, described here. In this case, we can look at the C. So estimate, standard error, z-value, probability, which is a total effect. So if you check these 2 numbers, they are exactly the same, okay? Here, okay, yeah. This number and this number, and also the standard errors are the same, okay? And also the z-value and the probabilities. So that, so it just verified the equation that C is A times B plus C prime, the sum of the direct effect and the indirect effect. So that's R. We can also use M plus to do the same analysis, to conduct the same analysis. So M plus is very powerful, but it's a commercial software. So R is free. You can just download and run the data analysis. But M plus, there's also some, there's also demo version of M plus, which is free, okay? But the full version of M plus, yeah, you have to pay for that because it's a commercial software. So we have title, we have data, we have some keywords. This is the syntax of M plus for the mediation. So let's look at the format. So we have some keywords here, and also we have some, yeah, variable described here, and model described here, and some, yeah, special command for mediation described here. So let's look at the keywords in M plus. We have title, yeah, title, mediation analysis. We have data. So we're gonna tell M plus, where's your data? Well, which one is your data file? So file, so I call it M plus data.txt. So this is my file. And on the data, we have variables, okay, variables. So we have keywords, for example, names. Names actually is the column names of the data inside this file. Okay, so inside the M plus data, I'm gonna show you the data file in 1 minute. And we have 3 columns, and the column names are ME, HE, math. And the other keywords, okay, so yeah, we're gonna skip missing, and then use variable. Use variable is the variables you're gonna include in your model. So names, you have to include all the columns inside this file, but it's not necessary for you to use all the columns. You can just pick some variables inside this column and to set up your model. So use variables, describe the variables you're gonna use in your model. Of course, in this case, we only have 3 variables. We're gonna use all of them, ME, HE, and math. If it's complete data, so you can, that's it. You don't need to do anything. But if you have some missing values, you're gonna include these keywords missing. And after that, you're gonna tell M plus the format of missing data, for example, negative 999 or yeah, whatever. So you have some format, you have some symbols for missing data. So you have to specify here, but our data is complete. So in this case, we do not use a missing command. And after that, we have model. Model, here we have 2 lines. One is, okay, math on MEHE. So in addition, so we have math, HE, and we also have a keyword on here. And the second equation, okay, HE on math. So what does that mean? So we have on here. On actually describe a model. So on means regression. So the variable before on actually is a dependent variable. So math is regressed on. On is short for is regressed on these 2 variables. So these 2 are independent variables. And HE on ME. So dependent variable HE is regressed on ME. So this is an independent variable. This is a dependent variable. So on defines a model. So I give you a summary table, tells us all the important keywords. So we just talk about on here, and we have regression model. If you use by in M+, then it defines a latent variable. So in your factor analysis, you're gonna use by a lot. You have a lot of latent factors. And also, if we use keyword with, then it will report the covariance, calculate the covariance for us. Okay, for example, F1 with F2. So the covariance between F1 and F2 will be reported. And if you just list a variables, that means the variance of those variables, or in some cases, the residual variance, if it's dependent variable, then will be reported. Okay, but if you add bracket of these variables, then the mean part will be reported. For example, here, okay, F1 or Y1219 brackets, or mean part, okay, the mean, average, intercept, or threshold, if it's a categorical variable, so will be reported. And sometimes you use the asterisk to show some special meaning. In M+, it's gonna free some default value, because by default, they set some values for us. But if you want to free that value, you're gonna use asterisk or freeze. If you want to specify a starting value, you can also use this symbol. Okay, so for example, Y1 asterisk. So it will free that default value. And after that, we will have 0.5. So the starting value will be specified for Y2. On the other hand, if you're trying to fix a variable at some value, then you're gonna use at sign here. So it will fix a value. For example, Y1 at something, okay, at a default value. Or you specify a value, okay, Y2 at 0. So the Y2 will be fixed at 0. So it is not parameter in that case because it's a constant. And sometimes you use a parenthesis, okay, with a number to show, put some constraint, okay, to show some constraint. In that case, you put some constraint on this model. For example, F1 on X1. So what does that mean? F1 is a dependent variable. It's regression on X1. The coefficient is, okay, put parentheses with 1 here. And there's another statement with the same number. So what does that mean? The coefficient will be equal. So here we have coefficient from X1 to F1. So there's another coefficient from X2 to F2. But this coefficient will be set equal. So this is the meaning of the parentheses. So I just give you some examples of in plus. Let's look at the code here. We also have model indirect. Okay, model indirect is especially is designed special for the mediation effect. Model indirect. So it's used to request mediation effect or indirect effect. And all the total effect, indirect effect, and indirect effect will be reported when you have this statement. And also there are some keywords. For example, we have IND or VIA. So these are examples. We have EPT1, IND, age, and EPT1, IND. There are a bunch of variables. And we have VIA. So what does that mean? So just look at the IND first. IND is a variable on, okay, IND also tells us the path, okay. So the variable on the left hand of the IND is a dependent variable. So for example here, okay, all of these are dependent variables. And the variables on the right hand side of the equation, for example, these are mediator or independent variables, okay. So the last variable on the right hand side of the IND is an independent variable. For example, here, age is independent variable, and here, age is independent variable. But we also have some other variables involved here. Those are mediators, okay? Other variables on the right-hand side of the IND are mediating variables. Sometimes you may have more than one mediating variables. For example, in this case, we have 2, okay? But if there's no mediating variables specified, for example, in this case, then all possible indirect effect will be reported. Okay, so here from age to EPT, all the indirect effect will be reported. But if you specify some variable, mediating variable here, then from age to HVLTT1 to WS1 and to the dependent variable EPT1 will be reported. That is a specific path. Okay. Here, all of these paths will be reported. And we have total indirect, okay, and the total effect, okay. So that's for IND. So VIA, let's look at VIA. It's quite similar as IND. So the left side of VIA is a dependent variable. So this is a dependent variable, and the VIA. The last one is the independent variable. So in this case, this age is independent variable, but we do have WS. So if you use a VIA, then all possible, okay, all indirect effect that go from the independent variable via WS1 to EPT1 will be reported. Okay, not specific here, it's specific, but here, all possible indirect from independent variable to this mediator to the dependent variable will be reported. Okay. Yeah, this is a meaning of these 3 examples. EPT1, IND, age that gives all indirect effects from age, okay, age independent variable to the dependent variable EPT1. And this is specific, okay, give the specific path from the independent variable age here to HVLTT1 to WS1 to EPT1. Okay, this is one path only. But if you VIA, then all possible paths from age via WS1 to EPT1 will be reported. Okay, so after you run the code described here, so title, data, variable, okay, use variable names and model, these 2 equations here, and the model indirect, and the math, okay, dependent variable here, IND, okay, ME, okay. So from ME to HE to math. And we also look at the variance of ME because it's an independent variable. So, and after you run the code described there in this slides, we will have the output. So in the output of the M plus, we have different portions. So the one part is about model fit. So model fit, we have number of, let me just remove this part. We have number of free parameters, okay, 9. We have likelihood, we have IC values, AIC value, BIC value, SSBIC value, and also chi-square value. Degrees of freedom is again 0, okay. RMSEA, okay, CFI, TLI. And this is for the baseline model. Baseline model is kind of like an independent model, so it's empty model. So this is a worst model. So usually we do not need to look at this part. And also we have SRMR. So for these two, okay, RMSE and SRMR, we compare those numbers with 0. So closer to 0, a better model fit. Okay, but for CFI and TLI, we compare those values with 1. So closer to 1, usually it indicates a better model. And the EIC, BIC, SSF, BIC are all for model comparisons, but here we do not have a second model, so we do not need to look at the model comparisons. So model evaluations are reported by, okay, RMSEA, CFI, TLI, SRMR. A number of free parameters, okay, it's 9. Why it's 9? Because we have we have where the path diagram. Yeah, we have 3 parameters here, A, B, C prime. We also have 3 variances, okay, S1, S2, S3. And we have 2 means, okay, so mean of the HE, mean of the math, the dependent variable part. So and also we have mean of the independent variable. So in total we have 9. So that's for M plus. It combines the mean structure and the covariance structure together. So the number of parameters is 9. But if you look at R actually look at the covariance part only. So it does not contain the mean part unless you specify the mean structure is true. Okay. And we also have the model result. Okay, so we have coefficient math on ME. So if you check the path diagram, math on ME, which is math on ME, it's a C prime here, okay. And we have math on HE, which is B, coefficient B here. And the HE on ME, which is A, this is A coefficient. And the standard errors, Z value, P values are reported. And intercepts, okay, these 2 are for the dependent variable, HE and the math. And the residual variance, HE and math, okay. In addition to the model results, we also have the mediation effect reported. So total indirect, specific indirect, and direct effects will be reported here. So let's look at the format of this part. So basically, so in the beginning part, it will just report from some variable to another variable. Okay, here's effects from ME to math. Okay, independent variable here and to math, dependent variable here. And then it will report a total first. Total is a C, okay, total effect. This is a sum of total indirect and direct, okay. So total indirect here, this is a total indirect. And under total indirect, we have specific indirect. So each possible path will be reported in this portion, this part. And of course, this is a really simple model. So we only have one specific indirect. And the next example, I will show you, yeah, it could be many indirect effects, but the sum, okay, if you add all of these specific indirect, we have the total indirect. This is the total indirect. And we also have direct, okay, direct effect from ME to math. So this is a C prime plus total indirect is the total effect. This is a total effect. Okay. So if you try, if you want to look at try to look at the A times B, then that's it. Or this is the same one. Okay. So it tells us significant because it's less than 0.05. If the alpha level is 0.05, then it's significant. And this is a magnitude. Okay. And it's positive. Okay. Okay, so that's example 1. So we can just open R. So let me show you the M plus and R. So let me stop sharing of this one and we can look at the R. So share, oh, wait a minute. Sharing, where's my R here? This is R Studio. And we have the code, included here. This is the syntax. So in the beginning, so you need to install the package of BMEM, and you can also add the package of SEM and use library to make these 2 packages available for you. And of course, in order to input the data file, you need to set the working directory. So let me, I think I have already, yeah, I already done this previously. So my working directory is my data file location. And then the data file is saved as rdata.txt. So I use read.table, and include the file here, and the head equals true because the file, let's look at the file, rdata here. Oh, let me share my file. So it's very simple. We have just 3 columns here. So we have column name and MEHE math, and we have 3 columns of numbers. So that's it. That's our data.txt. So let me close that and go to R again. R Studio. So header equals true. And then we save that data file to DS, okay, data set inside R. And we can use head to check the beginning part of the file. So here we have MEHE math, okay, the beginning 6 rows of the data file. And you can check the sample size, use n row. Is 371. Okay, that is our sample size. And then we're gonna look at the specified model. Okay, we're gonna look at the model. Okay, second step, specify our model. And I just repeated
I'm still not sure about that.
Sorry. So I'm gonna repeat all of these parameters here. And if we click run, oh, I didn't use a library BMEM and SEM, so that's why there's an error message. And make these 2 packages available for us. And then run it again. So the model has been included in the R. And then we define the indirect effect as A times B and use a BMEM.sobel do the test. So let's try to run this part. That's it. So we have the coefficient, okay, A, B, C prime, S1, S2, S3, and the indirect effect, okay, A times B here. And if you want to look at the summary of the SEM part, then that's it. We also have the model fit information here. And these including the indirect effect and the total effect. So combine these 2 parts. And we have the total effect reported here in addition to the indirect effect. Okay. So that's a, oh yeah, that's a mediation. So if you want to check the total effect, then this part is for the total effect. So simple mediation, simple regression model. Okay. So that is our model. And we have the, we have the covariance matrix part here. And we can just check the total effect. So C here is reported here, the same value as we obtained by running the mediation model. So that's R. Let's look at M plus. M plus, let me share the screen mode. M plus, where is it here? Yeah, that is the code, that is syntax of M plus. We have title, data, and variable, model, okay, and model indirect. So the data file is called M plus data because for M plus the column names are not allowed. So I just deleted the first row, and inside variables I define the column names here. Okay, so we have 3 columns. These are column names. And in case we have missing values, I also added the missing value, but actually there's no missing value. Okay, and we use variable include all of them. So in M plus, it's quite simple. You only need to click 1, and that's a result. Okay, that's outcome. Yeah, it first repeat the input file of the model, and then the variable information. Okay, so number of groups, number of observations, and number of dependent variable. Okay, here we have 2. We have 2 dependent variables. One is HE, one is math. We have 2 equations. For each equation, we have 1 dependent variable. And the number of independent variables, we only have 1. Okay, ME, mother's education, is the only independent variable. Okay, sample size, okay, 371. Number of groups, just 1. We didn't do the multiple group analysis, so 1 group. Number of continuous latent variables. In this case, in this model, we didn't create any latent variables, so 0, okay, 0 latent variables. And it gives us specific variable names. For example, the observed dependent variable continuous 2. Okay, we have 2 dependent variables, HE and math, 2 equations, and 1 observed independent variable. Okay, ME here, ME here. And the next portion is about the algorithm part, or the other, for example, ML, so maximum likelihood estimation method. And the information matrix, we use observed information matrix. And we have some other settings, maximum number of the iteration numbers. For example, by default, we use 2000. And the input file name here, and data format, and a summary of data, so no missing values because there's only 1 pattern of the data. And some values for the proportion, actually, variance. And this is the descriptive statistics for each variable described in the model. Okay, so we have 3 variables, HEME, math, so sample size, okay, sample size, and mean and variance. Okay, mean is reported here, and the variance here, and the mean of math, mean of variance of math, and the skewness kurtosis also reported here. Minimum, okay, maximum, percentage, okay, percentile of all of these. And then the model fit information, as I described. We have number of free parameters, including the mean part and the covariance part. And the log likelihood values, information values, chi-square value, RMSEA, CLI, TLI. And for the baseline model, okay, you can know this part, and SR and R. After that is model result, the coefficient part. coefficient, the parameter, okay, parameter estimate, including these three coefficients and the mean of the independent variable, the mean of the two dependent variables, and the variance, okay, variance of the independent variable, residual variance of two, okay, dependent variables. So we have estimate, we have standard error, we have z-ratio, we have p-value. And finally, we have the mediation effect reported. So we have total indirect, specific indirect, and the direct effect. Okay. So we have already explained this part in our slides. That's it. That's the end of the analysis. Okay. So that's M plus. Let me stop sharing here. Let's look at let's go back to our slides. Okay, so that's a first example. That's the first example. Okay, now it's 9:10. So let's have a break, and then we will continue the second example, which is a little bit more complicated. Okay, so we have more variables involved. And then we move to the bootstrapping method and the missing values and also advanced mediation models. Okay, let's have a break. Let me stop sharing here.